Hey, good morning, everyone. Hope you had a good weekend. We are pretty much at the end of our schedule here. If you remember, we were talking about we needed to finish up the systems of equations, and that's what your homework was about, those word problems. We'll talk about that in a moment because I'm sure you might have some questions. But we are going to go back today to earlier in the semester in the schedule when we had skipped over percents, proportions, applications, mixture problems, and then also scientific notation and different metric system, things like that. So we're going to go back and do that. That's what we'll be going over for the next couple of days. We only have, I believe, let's see, we meet twice this week. We meet once next week because Thanksgiving. So that's 3 meetings. And then we have 4 or 5, I think 5 classes left. And then the following week will be the final. And our final is on, let's see, Thursday, December 9th. So yeah, we're down to 5 classes. So we'll probably do, of those 5 classes, the next 3 of them will probably be new material. And then we'll probably spend the last 2 classes just talking about the final, getting ready for the final, going over review and things like that. So are there any questions as to where we are, what we're doing, what the plan is? Everybody clear?
Will you have office hours today? Because I was struggling. I don't think we went over the homework from it was a logarithm. So I'm struggling on those questions a little.
I had office hours before class for an hour, and then after class from 11 to right around 1 o'clock, I have office hours. Yeah, but we can talk about any questions that you might have.
It was just a couple questions. I think it was from page 199. Yeah.
Okay. Yeah.
I was having trouble with question 15 and 18.
15 and 18. Okay, yeah. Let me grab that first.
I
Yes.
have my internet is very unstable because I'm on vacation and the Wi-Fi went out and I'm using my hotspot. So if I leave,
Yeah.
that's probably why.
I understand. That's fine. Thank you for letting me know.
You're welcome.
Have fun.
Thank you.
Okay, so let me go back to remind everyone how we do this, okay? Because I think that's will help us as we proceed here. The whole idea behind the solving of an equation where you have a variable x that's up in the exponent, it involves this converting it to a logarithm and then using your calculator to solve. So anytime we're asked to solve something where x is up in the exponent, we need to first convert it to a log. Then once we get to the log, we do our we use this thing called the change of base formula, and then we use our calculator. Okay, so just so everyone knows what I'm about to do, okay? We did cover this. So here's the challenge of this problem. This is why this one's a little different. If I were, let's do this. If I were to give you a problem that looked like this, 4 to the t equals, let's say 12. Okay, let's do that problem first. If we were to do this problem, what we realize is, or what we need to realize is that we have the number 4, right, being raised to some power t, and then equals a number on the other side, 12, right? So we're trying to solve for t. T is up in the exponent. So what we can do is convert this to a log. And when I say convert that to a log, what I mean is, let me zoom out here. No. What I mean is We had talked about this when you convert an exponential form over to a logarithmic form, you first start with the base here 4, you put that down here as your base. And then remember me talking to you all about this idea of like a loop kind of. So I'm going to read this equation and I'm going to fill in the loop. Now, again, the 4 is the base here, so that's what goes down here. So 4, right? And then this loop is what I'm raising it to, right? I'm raising the 4 to t, so this side is t. And then that must equal, well, what does this equal? It equals 12, so the 12 goes here. So we have log base 4 of 12 equals t. And then we use that change of base formula that I showed you. Where was it? Right here. That if you had, I'll just copy this. Let me just copy this real quick. So if I'm trying to solve this, right, I can use this formula where the 4 is like the a. Okay, so that's going to go here. And then the x is like the 12, and that goes here. So basically, the left-hand side turns into the natural log of 12 divided by the natural log of 4 equals t. Does that make sense? You okay with that? Everyone good, or questions? You get my calculator now.
Is this going to be on our next test log?
Yes. Mhm.
Okay.
This will be on the final. Yeah. So log of 12, and I divide that by log of 4. And just so you know, when I'm typing that into my calculator, here's what it looks like. I'm doing natural log parenthesis 12, then the division key, then natural log again, parenthesis 4, close parenthesis. That's what I'm typing into my calculator. Then I hit enter and I get 1.79. Let's just go 1.792 approximately. That's what t is. Okay, so that's the basic idea behind solving an exponential equation. So solving for a variable that's up in the exponent. Now on this one, I think what gets tricky on this one is you have to identify what's the thing being raised to the t, right? Like over here, it was the 4, but for us over here, it's this piece right here. This whole thing in yellow is what's being raised to the t. Now, the way the problem is presented is probably a little confusing because they put 1 plus 0.01. We could just add these two together. That's just 1.01 to the t. Like there's no reason that those have to be separated. So if we look at this now, it's looking a little bit closer to this, except we have one big difference. We have this 500 sitting in front. Okay, that 500 in front is a problem because we can't convert this to a log until we have the thing that's being raised, right, to that power. That has to be isolated. Like this has to be by itself on one side of the equation. We can't have anything else with it. So how do you think I could get rid of that 500 that's in front of it? What do you think?
Divide it.
Divide, yeah, let's divide, right? Let's divide 500 on both sides. So if we divide that, then it will go away. It'll go away. Come on. It'll go away over here. And then here we have 2, right? 1,000 divided by 500 is 2, equals 1.01 to the t. And now we can do the log, okay? Because we have something raised to a power equals a number. So I'm going to go ahead and convert this. So log, now the base here will be the thing in yellow, so 1.01. And then I'm going to be doing this loop thing. So the right side will be t, because I'm taking the 1.01, raising it to t, and that must be equal to this number here, 2. And then I use my change of base formula. The left side becomes natural log 2 over natural log of 1.01 equals t. And then I get my calculator again. So natural log 2, divide that by natural log 1.01. And I get a pretty big number. It's 69.66 is approximately t. Does that make sense? I think that there are two kind of major issues with this problem. The first issue is that, this right here looks weird. So convert it to a number and then everything's a little nicer. And then the other issue is this 500 that you have to get rid of it first. So now let me look at the other question you had. You said it was number 18. Is that correct? I didn't hear you. Thumbs up, yes? 18, okay. So 18. So when we look at 18, we have, again, something here, 4, being raised to the 3x equals a number. So I guess my question to you is, can I right now convert this to a log? I mean, do we have something to a power equals something? Is that what we have? Yeah, right, that's it. Okay, so I can go to a log now. Log, let's see, the base here will be the same as the base over there, 4. And then I'm raising 4 to the 3x, so 3x goes on this side, and then that is a 6 here. So it's kind of weird that we have a 3x there, but that's what the power is. So I put that whole thing on that side. And then the left side becomes natural log 6 over natural log 4 equals 3x. I get my calculator. Natural log 6 divided by natural log 4. And I get 1.29 is about 3x. Now we're supposed to solve for x here. Right now, we don't have it solved for x. It's a 3 in front of the x. So I'm just going to do some basic arithmetic here. I'm going to divide both sides by 3. And that should give me my x on the right side. And then if I take 1.29 divided by 3, I get about 0.43. All right, does that help?
A lot, thank you.
Okay, are there any other questions?
Yeah, can we do 14, please?
Did you say 14?
Yes.
Yep.
For the one above, is that one, so where you get x, is that still equal to, even though above it, it was like,
It's, yeah, you could say it like squiggly. It's
Oh, okay.
approximately, because we have to round. I mean, like when I got this 1.29, I rounded it on my calculator. It's actually 1.29248,125. But, for this class, we just, round it 2 decimal
Okay.
places, we're fine. Okay, so on this one, can you tell what's being raised here? What's the thing that's being raised to the power?
Would it be 25?
How do you mean? Like in this problem right here, the 4 is the thing that's being raised, right? The 4 is being raised to the 3x, right? And so the base here is 4. My question is on this one, what is the thing that's being raised to a power? Is it the 25? Is it the 50? Is it the E? What is the thing being raised?
The E.
The E, okay, the E is being raised to this power. Now that's a weird way to write it, but this is really like 10,000 times K, all right? K is like X, it's just a variable, all right? We could put the variable in front or in back. They should have put a dot here actually, but it's okay. So right now, can I go to the log? Can I do the little log thing now? Do I have the thing that's being raised to the power by itself? What's wrong with this? I have that 50, right? That 50 in front?
Yes.
Yeah, 50 can't be there. Also, I want to point something out, just so y'all are clear on this. Just think about this, just to make sure you understand. If I write 4x squared, you need to understand that the only thing being squared here is the x. Okay, the squaring is happening on the x. not on the 4. If I write 4x and then squared, now the squared is acting on both of them. So this power right here, k times 10,000, is only acting on the e. It is not acting on the 50. If I had this in parentheses, well, then that would be a different story, but that's not what we have. So the 50 is by itself out in front being multiplied. There's like a multiplication symbol there. So I need to get rid of that. So I'm going to divide by 50 on both sides. And that will kill off the 50. Now on the left side, you do that, you get 0.5 equals e to the, again, I'm going to write it 10,000 k. And now I have something raised to a power equals a number. So I can go to the loop or to the log. So I put log, my base is e, and then the other side is going to be 10,000 k, and then here will be 0.5. Now you have two options here. One option is to use your change of base formula. Okay, so this is one way you can do this is right. The left side is natural log 5 over natural log of e equals 10,000 k. And the thing about this is how do you typing in natural log of 5 is easy, right? Just type in natural log of 5, but then you divide that by natural log of e. And so how do you do that on your calculator? It's kind of weird. You do natural log 5 divided by natural log, then you hit that E button. And when you do the E button, which is the green button above the natural log, it's going to come up and it's going to go E, and it's going to put a little box here. And you have to type something in there. And since we want E, all we do is put a 1 there, because anything to the 1 powers itself. So I'm just going to put 1, hit enter, and you should get about 1.609. So this should be about 1.609 equals 10,000 k. And then I have to divide by 10,000 on both sides. If I divide by 10,000, I get a very small number, 0.001609 equals k. Okay, that's the first option. Okay, this right here, what I just did is kind of option A. Option B is to remember that when I was telling you about logs, anytime your base is E, that this really just means natural log of 5. That's what it means. So natural log of 5 equals 10,000 k. You could have done this also. And if you do that, you do natural log of 5, you'll get the same thing on the left side. You get 1.609 equals 10,000 k. And then you get the same answer. So that only happens when your base is E. That's the only time that it just becomes a natural log. If this is something other than E, then you have to do, kind of like we did here. Is that clear? Any other questions?
Okay, number 10, please.
Number 10. So I was looking in the chat about exam 4. So I think what we had discussed as a class is that it would be kind of tight to squeeze an exam 4 in here, because we'd have to do it either like the day before Thanksgiving next week, or we'd have to do it after Thanksgiving, which is the week before finals. So what I said is that everyone, we're gonna skip exam 4. Everyone's gonna take the final, and then the exam 4 grade will be replaced with your highest exam grade out of all the exams you've taken. Okay, so if exam 1 is your highest grade, that'll become your exam 4. If your final exam is your highest grade, that'll become exam 4. Okay, number 10. There will be a review for the final. Okay, on this one, I think what's probably confusing, there's a few things confusing, but we have a 5, right? It's being raised to this whole thing. and that equals a number, because 1 divided by 125 is just a number, right? So we should be able to do our log right now. Log base 5. The other side, so we're raising 5 to 2 minus x. So I write down here 2 minus x, and that must equal the 1 over 125. So I've created my logarithm now. And let's just do on our calculator 1 divided by 125. Let's just do that so we can get a decimal. This is the same as log base 5 of 0.008 equals 2 minus x. So all I did there was just did that on my calculator. So now I'm going to convert using the change base formula. This is going to be natural log of 0.008 over natural log of 5 equals 2 minus x. And then I use my calculator to do this. So I get -3 here on the left side equals 2 minus x. And this right here is just a linear equation. I'm going to solve for x now. So I'm going to take 2 away, take 2 away. That gives me -5 equals -x. And then the final step is I'm going to divide by -1. And I'm doing that so I can turn that -x to a positive x. So I get x over here and equals negative divided by negative is positive. So we get 5. That makes sense?
Yeah.
Yes. Okay, how about questions over the homework? Are there any questions on those solving those word problems?
I ended up going to the math lab to do it.
Yeah,
And I know the one thing that I noticed is being able to form the problems. So I ended up like, I guess you could say for number 11, I had to
Mhm.
look and just, I guess my hardest was identifying the X and the Y. You know what I mean? I ended up
Mhm.
solving them all, but I noticed that was where I was having the hardest time is setting it up from the.
yeah, like figuring out like what is it you're looking for, right?
Yeah,
What is X going to be? What is Y going to be?
exactly.
Yeah. Yeah, and that's what makes the word problems hard is because, you know, if I just give you a system of equations, right? If I just give you a system, most students are going to be like, oh, okay, yeah, I can do substitution or elimination, and you get comfortable with that. But if you have to come up with the system, you know, by reading the word problem, that's where it gets challenging, right? So are there any of these odd ones? Because I did all the evens, right? Are there any odd ones that you want me to run through here?
Can we do number 11?
Yeah, I think 11 was probably the hardest one.
Yeah, I think so.
Yeah, let's do it. I think it's
Yeah,
hard. You have to know a little bit about basketball to do this problem. John, what'd you say?
Yeah, that's what I was gonna say. In the math lab, the tutor and I, that was the one we had the hardest trouble with, was that
Yeah.
one, number 11.
Yeah. Okay, so Tim Duncan, right? You all know who Tim Duncan is, of the San Antonio Spurs, once scored 36 points on 22 shots in an NBA game. All right. He shot only 2-point and free throws. So again, you have to know about basketball. So when you shoot a basket, you can shoot a basket and it's either worth 3 points, 2 points, or 1 point, depending on where you shoot it from. So they're telling you that he only shot 2-pointers and 1-pointers. So there's no 3-pointers here, only 2s and 1s. All right. When you're trying to figure out what X and Y is, you have to read what they're asking for. So you want to know how many of each type of shot he made, right? So he made 2 types of shots. Okay, he made 2-pointers and 1-pointers. Those are the 2 types of shots. Or you could say 2-pointers and free throws. It doesn't matter how you say it. It's just you need to know that one of the things you're looking for is how many 2-point shots he made. And the other thing you're looking for is how many 1-point shots he made. Does that make sense to you? That's what I'm gonna call X and Y. Like
So-
X is gonna be, go ahead.
Sorry. So whenever I set it up, I don't know if I set it up correctly, but I did the 2 pointers as X and then the free throws as Y. So I did 2X plus 1Y equals 22.
Yeah, hold on a second. I'll get to that. Hold that thought. 2-point shots, right? X is going to be the number. I didn't put number of 2-point shots. X is going to be equal to the number of 2-point shots that he made, right? And then Y is going to be equal to the number of 1-point shots he made. All right. Okay, now go ahead, Alexandra.
I just don't know if whenever I set it up, if throwing the numbers for the points was correct, putting it in the equation.
Okay, so you said something about, what did you say? Like one of the equations you set up was?
It was 2X plus 1Y equals 22. I didn't know if we were supposed to, because he did 22 shots.
Okay, yeah. So, okay, let me ask you. He took 22 shots, right?
Mhm.
Total. I mean, not total. This is such a bad question, okay? I didn't write this question.
It's okay.
It should say 22 made shots because he could have missed some, all right? It doesn't say that he made these, but we're gonna assume that the 22 shots that they're talking about are the ones he made. Okay, so if he took 22 shots, he could have done 11 and 11, right? 11 2-pointers and 11 1-pointers. He could have done one 2-pointer and 21 1-pointers, right? There's all these different combinations of what he could do. The X and the Y is how many shots he took. The X and the Y does not account for how many points
Okay,
he got, right?
gotcha.
So the first equation should be, well, you tell me, what should 22 be then? It's the total number of both types of shots he took, right?
Mhm.
So
So
that
really
should be
Just be X plus Y.
X plus Y. There you go, X plus Y. Okay, so think about it this way. If X is the number of 2-point shots he made, we're saying the number of 2-point shots he made plus the number of 1-point shots he made is equal to 22 total shots, right?
Right.
So that takes care of that yellow part. Now, the 36, now we're talking about points, right? So for each of these 2-point shots that he made, right? For each of these, he gets 2 points. So if I multiply that X by 2, right? 2 times X will give me how many points he got from the 2-point shots. If I add to that 1 times Y, because he gets 1 point for each Y, for each shot that's worth 1 point,
And then
that should total what?
36 points.
36.
Okay.
And there's your system.
I did it different and I got the,
Me too. That's what I want to say. Sorry.
So what did you do differently?
I did Y equals 22 minus X. And then for my other one, I did 2X plus 1Y equals 36.
And then
Yeah,
I
that's
did
okay.
that. And I
That's
did the
okay.
X plus 36 minus 24 equal 22. So
Wait,
I don't
what?
know. That's what I put on the X plus 36 minus 24 on the 36. So I don't know if I did it right or wrong, but that's what I did.
Well, did you have a system of equations? Did you have that first equation or no?
Yes, I got that one, the X plus Y equal 22, I got that.
Okay, and then you had another equation that was what?
I put X equal 36 minus 24 equal 22. I don't know if I did it right or wrong.
Yeah, that seems, that seems, I'm trying to understand your logic for it, like why you came up with that, but
And then after that, I put x equal 22 minus 36. So I don't know.
yeah, that, okay, so I think what you're trying to, I don't know, but I think what you're trying to do was somehow combine these two together.
That I think that's yeah, that's what I
Yeah.
did.
Okay, let me try and I'm gonna try and give you a different example, which might be easier for you to grasp, for everyone. Let's say you go, I'm trying to make this make sense. Okay, so let's say that you go to buy lunch, okay? And you're gonna treat your friends to lunch, right? You all go out to lunch and you're gonna buy hamburgers and drinks. That's it, okay? Hamburgers and drinks. So you have hamburgers and drinks. And I tell you, okay, I tell you that you bought 22 items. Okay, you bought 22 items. All right. And I tell you that you spent $36. And I tell you that a hamburger is $2. Now I know this isn't, these must be really cheap hamburgers, and a drink is $1. This is the exact same problem as the one we're doing. Because the number of items, right, is the total number of hamburgers and drinks together. So like X would be the number of hamburgers, and Y would be the number of drinks. Let's figure out how many of each. So when you say 22 items, that means the number of hamburgers that you bought plus the number of drinks you bought had to be 22. And then to spend $36 means that for every hamburger you bought, you spent $2. So you have to say $2 times each hamburger plus $1 times each drink. That should be equal to $36. I don't know if that makes any more sense, but it's the hamburger cost here, the $2 and $1 is like the value of each of these shots. One type of shot is worth 2 points. The other shot is worth 1 point. So that's like the $2 and $1. That make any more sense? I don't know.
Yes,
I'm
it makes
trying.
sense. It
I'm
makes
trying.
sense. Yeah, now I understand. Yes, it makes sense. Thank you.
Okay. All right. So then how about solving that system? Are y'all okay solving that, or? I mean, you have different ways you could do the system here. So I'll just go ahead and finish this off. If I were doing this problem, if it were me, okay, what I would do is I would try and I would do elimination. I like elimination. And I would see that my Y's will cancel if I multiply the top equation by -1. So if I do that, I get a new system, becomes -x minus y equals -22. And then the bottom equation doesn't change. And I think I remember when I was doing these solutions for y'all, I think I messed up on one of them and I found out, I like realized it afterwards. So just to show you, be careful when you distribute this through, make sure you hit all of them with it. Now we add down, the Y's will cancel. You should get -x and 2x is just x. And over here, this should give you, what is that, 14? So x is 14. So once you find x, then you take any equation you want. So I'll take that equation up there, x plus y is 22. I replace the x with 14. And then I subtract 14 on both sides and I get 8. Which means that he took 14 2-point shots. And he took 8 1-point shots. And you can check your work. How many shots did he take total, right? 14 and 8, that adds up to be 22. How many points did he score? Well, each of these 14 2-point shots are worth 2, right? So 14 times 2 is 28. So he has 28 points. And then he took 8 one-pointers. So add another 8 points to 28, you get 36. Okay. I hope that helped. Are we ready to move on with today's stuff? All right, so we are backing up really far into the class, into the very beginning of the class. We were supposed to start talking about fractions, percentages, proportions. And so I think you might find some of this to be a little easier than the stuff we've done, because we were supposed to, so early in the class, we didn't have to develop any ideas for it. So, and then also this is something a lot of you are familiar with, all right? Fractions, something we deal with almost on a daily basis. We see fractions and ratios all over the place. So let's just make sure we understand what a fraction is. A fraction, also called a ratio, is any number of the form a over b, where a is the numerator and b is the what we call the denominator, right? So we've seen this before. For simplicity, a fraction may also be thought of as part over whole. Okay, what do I mean by that? Part over whole. So a fraction is a part of something over the whole. So let's discuss this a little bit more. If I write the fraction 2 over 5, all right, what we mean by this visually is that, and I think we can do this with different things, pizza slices, or I like to do like a candy bar. If you take a candy bar and you cut this into 5 equal pieces, okay, so you have 5 equal pieces. When you say 2 over 5, you mean take 2 of the 5 pieces. So there were 5 pieces, you're taking 2 of them. So the 2 is the part that you're taking from the 5, which makes up the whole thing. So 2 over 5, that picture represents this fraction. Now, what about this? What about 1 over 5? Not much different there, right? You still take a candy bar, cut it up into how many pieces? So how many pieces?
5 pieces.
5 equal pieces, right? 1, 2, 3, 4. So there's 5 equal pieces, and we're only taking 1 of them. So this is what 2/5 is, or 2 over 5. This is what 1 over 5 is. How about this? I'll do it over here. How about 0 over 5? So you're still going to take a candy bar, right? You're going to do 5 equal pieces, right? And how many of them are you taking?
None.
None. So how much do you have? How much did you take? You didn't take anything, right? Like here you took 2 out of 5 pieces. Here you took 1 out of the 5 pieces. So you know, in each of these cases, you got something, right? Here, you cut the bar into 5 pieces, but you didn't take any of them, right? You didn't take any of them with you. You just left it alone. So how many do you have in your hand? Nothing, right? That's why 0 divided by 5 is the number 0. That makes sense?
Yeah.
What about this? What about this fraction? 2 over 1. So if I take a candy bar, how many pieces do I cut it into? This was 5 equal pieces, 5 equal pieces, 5 equal pieces. Here, this should be 1 equal piece, right? 1 equal piece, which is just the whole bar, isn't it? The whole candy bar is just 1 piece. How many of them am I going to take?
2.
2 of those whole bars is what I want. So I'm going to take this one, and I need another bar, and that's why 2 over 1 is 2. Does that make sense, y'all? The bottom is how many parts you're going to cut the bar into, and the top is how much of it you're going to take. Now, what about this? I'm doing all this because I want you to see if you can understand why this is a problem. What if I write 5/0? What's wrong with this? I mean, all of you should be thinking, look, you should be saying, hey, so, you know, we've been told in the past you can't divide by 0, right? You'll remember hearing that? Division by 0, you're not allowed to do it, right? Let's see why you can't do it. This is saying I'm supposed to take a candy bar and cut it into how many pieces?
No pieces.
No, well, wait a minute. I have a candy bar. I have at least one piece, right?
Into
I
5.
can't take a candy bar and cut it into no pieces. And you can't say, well, then don't cut it, because if you don't cut it up, you still have one piece, right? So it's already a problem. But then we add another problem. Now I want to take 5. So how are you supposed to take 5 from nothing? This just doesn't make sense, which is why this is undefined. We don't have a way of defining this. It doesn't make sense in our number system. Division by 0 is not allowed because it doesn't make sense. I hope that that kind of helps you see why you're not allowed to divide by 0. Every other fraction you can ever come up with, you can find a way to represent it with candy bars and cut, you know, and slicing it up. Every other fraction out there you can. Well, there's one other that's a problem. This fraction is a problem too. 0/0. That's a problem because, yeah, that's still undefined. Okay, we're not going to get into that. All right, we're not going to get into this. So we'll go off on a tangent. I don't want to go there. Okay, so really we just need to understand what a fraction is, right? That it's parts that you're taking out of a whole, right? You're taking that whole and you're cutting it into a certain number of pieces. All right. Now, you've all heard percent before, right? You've all heard percent. In fact, let's do a poll. I'm going to launch a poll. And I'm going to give you a multiple choice question here. I'm going to ask, what do y'all want to know? What do y'all want me to ask y'all? Someone come up with a good question I can ask. It's going to be, it has to be a yes or no.
How many people have already decorated for Christmas?
How many of you, all right, have already decorated for Christmas? Can I vote? I can't vote. Okay. Yes or no, you've already decorated for Christmas. Is it launched? Is the poll launched? Yeah. I'm going to guess there's going to be a very, very high number of you who have
Not even December yet.
not. Yeah, tell my neighbors that. My neighbors already put up lights and
I always wait until Thanksgiving, after Thanksgiving.
Yeah, we already put up our Christmas tree.
I got my Christmas tree, but I need to decorate it.
all right, well, we don't have full participation.
Is choice 1 yes?
Choice 1 is yes. You
Correct.
have, yes, you have. Choice 2 is no, you have not.
I think it's because it actually got cold before January, and so everyone's like, oh, Christmas time.
Yeah. I mean, I do like to, if I'm going to put lights up on the house and have to get up on the roof or something, then I want to make it worth it. I don't want it to be for just a week, but I'm not ready to do it yet. Okay, here we go. We've got our results. So I'm going to share the results with you, and I'm going to copy this so we can all see it. What the heck? Hold on. Let me bring the poll in here. And then I'm going to, why is it not letting me? Huh. Oh, I see. Okay, so look at this right here. These are the results. All right. So when we look at this right here, 2 out of 14, right? 2 over 14, that is a fraction. It means that if you have all 14 students, 1, 2, 3, there's 14 students that participated in this, 2 of the 14, right? 2 of the 14 have already decorated for Christmas. And then the other fraction, 12 over 14, of course, means the other, right? of the 14 students, I mean, yeah, of the 14 students, 12 of them have, right? So a lot of them have not, have not. Okay, that's the fractions, but next to the fractions, it has a percentage, right? 14%, and then over here, 86%. What does percent mean, right? Like, we use it all the time, we see it all the time, but what does it mean? It is a way to do something, it's a way to represent a fraction in a kind of a universal way that you can convert every fraction to a percentage. And well, let me just get to what it means. Percent means out of 100. That's what it means. So when you write, let's say, when we wrote 14, well, when we had 14% here, it said, what that means is that 14 out of 100, which we could write as 14 over 100, right? As a fraction, 14 over 100 is our percentage of people who have decorated for Christmas. Now, I believe there's some rounding here. Let me see. Yeah, it rounded. It's actually, you know, let me change this because it didn't round this. This should actually be 14.28. I'm gonna round 14.28. So it's saying 14.28 out of 100 is 14.28 out of 100. So what it's saying, when we write a percentage, it's a way for us to like easily understand what's happening, right? If I say out of 100, most people can grasp the idea of how big or small that is. So when I say, oh, well, 14 out of 100, that's not many. But that doesn't mean we have 100 people here, right? Correct? I mean, we only have 14 people that answered that. This is saying there were only 14 people that took the survey. And this answer as a percentage is saying 14 out of 100 or 14.28 out of 100. We don't even have 14.28 people here. So it's really just a way for us to say, hey, look, if this class, if it had 100 people in it, and it were the same like proportion, then 14 of them out of the 100 would have decorated for Christmas. And that means that 18, let me see this 86. It's actually 85.71%, which means that 85.71 out of 100, which is 85.71 over 100, have not decorated. Again, when you say it out of 100, it's easier to understand how many people that is. It's a lot of people. 87 or 85 out of 100 have not decorated. So a percentage is universal. Let's do another poll, just a curiosity here. New poll. Hold on. Relaunch poll. Okay, so my question to you is this. Choice one is yes. No, choice one is you have an iPhone. Choice two is you have an Android. There is no choice three. iPhone for choice one, Android for choice two. I'm actually a little surprised here. All right, we don't have full participation, but this is good enough. We'll go with this. Whoa. That didn't work. Okay, so this was iPhone, and this was Android. All right, so I was expecting a higher percentage for iPhone. But that, I mean, that's still pretty high. So again, 8 out of 11 of the 11 students that responded, 8 of you have iPhones, 3 of you have Android. The 73% means if this class had 100 students in it, we would expect to see about 73 of the 100 have iPhones and 27 of the 100 have Androids. But it's only if we had 100, we don't have 100, right? Any questions? I mean, we just want to make sure we understand what a percentage represents. It's not the true fraction. It's the fraction adjusted to be out of 100. Questions on that? So, okay, let's talk about how we get from fractions to percentages. So how to convert from fraction over to a decimal and then over to a percentage. And then we also want to know how to go back the other way. All right, so let's do some examples. Let's say that I gave you, let's start with something easy, 3/4, 3 out of 4. I want to convert this to a decimal. So how do I convert that to a decimal? You either know what it is or you get your calculator out and you do 3 divided by 4, right? If you do 3 divided by 4, go ahead.
Would it be 0.75?
Yep, 0.75. Okay, so that's your answer as a decimal, right? 3 out of 4 people, 3 out of 4 people don't like math, okay, right? That's 0.75. Now, who knows how to get from a decimal to a percent? We've done this before also. How do you go from, so this is your fraction, this is your decimal, and now we're going to go to percent. How do you get a decimal to a percent?
Move it over to the right twice.
Move the decimal point to the right 2 places. So I take that decimal point and I move it to the right 1, 2. So that gives me 75%. So I have a shirt. Okay, I have a couple of shirts that are kind of math shirts. You know what? I'm gonna go grab it. Hold on, I'll be back. Okay, I couldn't find it. Oh, well. What it says on it, on the shirt, is that it says 5 out of 4 people hate math. That's what the shirt says. So it's supposed to be funny. I didn't get the shirt, I didn't buy it. It was given to me by someone. But why is that like funny?
Because if 5 out of 4 people hate math, then they don't really understand what they're, it's improper fraction.
Yeah, so 5 out of 4, wait a minute, hold on. That's more people that's more parts, right? You're taking more than the number of people. How can 5 out of, if I only have 4 people in this class and I asked you, do you like math? How could I possibly say that 5 out of 4 of you didn't like math? That's impossible for 5 out of 4. Does that make sense? It's supposed to be like the person who made that statement up is bad at math because they don't even understand math. Like you could say 4 out of 5 people don't like math, but to say 5 out of 4 means you don't understand fractions. So anyway, it's supposed to be funny, whatever. Let's do this though. Let's go 5 out of 4. Forget the problem. Forget that. Let's convert this fraction, convert it to a decimal. So if I convert that to a decimal, 5 divided by 4 on my calculator, I get 1.25. And if I go from that to a percentage, I take that decimal point and move it 2 places to the right, 125, and then I put the percent symbol. Okay. What about the other way around? What if we start with a percent? Can we get backwards to the other way? So let's do 35%. I want to convert that first to a decimal. So how do we get that to a decimal?
Move it over 2 spaces.
2 spaces,
0.35.
move the decimal point, right? Which is not written, but we have to understand it's right there. We move it this time to the left 2 places. So that will become 0.03, I'm sorry, not 0, 0.35 as a decimal, right? And then the tricky part, how do we convert that to a fraction? So when you write a decimal, this 3 is how many tenths you have. This 5 is how many 1/100ths you have. So 0.35 means that you have 35 out of 100. That's, I mean, just think about if I were to give you 35 over 100, right? On a calculator, that would give you 0.35. How do I, so all you have to do here is count the place value. So if you have a 3 and a 5, right, then this will be 35 over 100. Let me do another one. These we can do really fast. So how about just 5%? 5% as a decimal, move the decimal place 2 places, so you'll have 0.05. And now this 5 is the second digit, so I'm going to put just 5 over 100. I'll do another one, 2.1%. Convert that to a decimal, 0.021. You okay with that 0.021? Just move that decimal point 2 places to the left.
Yes.
Now, our digits go out to the 3rd position. Do y'all see that? This was 2 positions, this was 2 positions. Here it goes out to the 3rd position. Since you're in the 3rd position, you're going to write 21. So it's just take the decimal and the 0 away, just the 21, and then instead of over 100, you put it over 1,000. So the number of spaces you go over, 1, 2, 3, there's 3 of those digits, is how many zeros you have here. So if we go 2 digits, there's 2 zeros. So going from a decimal to a fraction is probably the hardest thing, the trickiest thing. Going the other way, it's just calculator and then move a decimal point. Okay, let's get back to the notes here. Percentages. Okay, what is a proportion? Now this is a word that gets people because they think a proportion is the same as a fraction. A proportion is an equation where you have a ratio equals a ratio. A ratio equals a ratio, or a fraction equals a fraction. So I'm going to give you a very, very simple example of a proportion. First, 1/2 is the same as 2/4. This is a proportion, or you could say that these are proportional. And the reason you can say it is because if I ask you to reduce this fraction on the right, 2 would go into each of those once and then twice, and then these are the same. So originally they were proportional. So let me show you how we can use proportions to solve solve like real world problems or word problems. So if you make $9,800 in 3 months, how much would you earn in 1 year? All right, so this, believe it or not, is a proportion problem. Watch the way I'm going to do this. I'm going to start with the given information. I make $9,800 in 3 months, right? I can write that two different ways, okay? As a ratio, not as a proportion, but as a ratio, I can write this in one of two ways. I can write this, we have two options. First option, second option. I can write it as $9,800 over 3 months. Or I could write it 3 months over $9,800. So when someone gives you a relationship between two things, the money and the time, right? The money you make and the time it takes you to make it, we can create two ratios out of that. The ratio of $9,800 over 3 months, or we can do the ratio 3 months over $9,800. Now, these right here are what we call our conversion factors, but we'll do that. We'll talk about that next class. So it's asking now, how much will you earn in 1 year, right? In 1 year. So when you look at these, don't
you multiply by 4?
Well, there's an easy way to do it with 4 because a year is 3 months, right? You need 3 months 4 times to get a year. I agree with you. You could do this without doing anything what I'm showing you here. But when the numbers get hard where you can't do that, we need a method. Okay, we need something like if I said, how much will you earn in 7 months? It's not as easy to convert. Does that make sense? It's not as simple. It's harder. So we want to know how much we're going to earn, right? How much will you earn? That's what we want to know. And we want to know how much you'll earn in 1 year, which for us is 12 months. Okay, let me just back up. We're told that we make $9,800 in 3 months. We want to know how much we're going to make in 12 months. So what is it that we want to know? What is it asking for?
In 12 months.
Well, in 12 months, but what? What in 12 months? They want to know what?
How much you,
Money, right? They want to know money. How much money, right? That's what we want to know. How much money are we going to make in 12 months? So when you look at these two right here, which one of these two has the money on top? The one on the left, right? The one on the left. So what I'm going to do is I'm going to write that ratio down. $9,800 over 3 months is proportional to X dollars over 12 months. So look what I'm doing here. What I'm trying to solve for, I put on top here, and what I was given there, the 1 year, the 12 months is on the bottom. You see that? Money years, or money months, right? Money in the months. I wanted to know the money in 12 months. So what I did is I set it equal to, because it's proportional to the money over months here. Money on top, months on the bottom. And now that you're here, all you have to do is cross multiply. Okay, so you multiply 9,800 times 12, and then 3 times X. Forget all the months and dollars. Let's just do the numbers. On the left side, 9,800 times 12. This gives you, I'm out of space here, 117600 equals 3X. And then divide both sides by 3, and you get $39,200 is X. So that's how much you would make in a year. money. We're running out of time. Let me do another one of these. I'm gonna do the same problem, okay? The same exact thing. But I'm gonna change the problem just a little bit. If you make $9,800 in 3 months, how much will you earn in, let's go with 17 months? So the first thing I do is I say, all right, well, look, I want to know how much I'm going to earn, right? I want to know the money. How much money am I going to make? So I want to know X dollars, right, over 17 months. That must be proportional to the money here over months, $9,800 over 3 months. And then you cross multiply. So this number is going to get big. 9,800 times 17 is 166,600. Hey, 666. And then 3x. And then divide by 3. So I get $55,533.33 is X. Yeah, it does seem like we see 666 a lot, don't we? I told you that though. It seems to always pop up. It's weird. Okay, I'm going to change problem one more time. Okay, if you make $9,800 in 3 months, the new question is this. How long will it take to make $134,500? What am I asking you for?
How long?
How long? How long? How long? That's time, right? That's time. That's time. So when you look at this here, right? I told you there was one of two ways you could write that, right? You could write it with the $9,800 on top and the months on the bottom, or you could do it the other way around. Since we're trying to figure out how much time it's going to take, right? We're trying to figure out X months over the $134,500. That must be proportional to, on this side, I need months over money this time, not money over months. So I'm going to put 3 months on top. And on the bottom, $9,800. Are y'all understanding the difference between this problem and the previous ones that we're solving for the time now? You see the
We
difference?
can only do it that way when we're solving for time.
This isn't the only way you can do it. I mean, there are other ways you can solve these problems, okay? What I'm trying to do is show you a way that's going to help you as we do other problems next class, next week. This will keep the same method the whole time. Now, if you have another way of doing, go ahead.
I'm sorry, I just meant like the months has to go on top in this
Yeah,
situation.
that's right. If you write X months over this money and you do over here 9,800 over 3, it'll be wrong. You always have to match, the proportions have to be equivalent. The units of what you're measuring have to be the same. So you have to have, it's either money on top, months on the bottom, or it's months on top, money on the bottom. But you can't swap one of them. That's what proportional means. It has to be equivalent. So now cross multiply. So I'm going to do 3 times 134,500. It's going to be a huge number. 400,000, 3,500 equals 9,800x. And now divide that by 98, divide both sides by 9,800. And I get 41.17 is approximately X. It's going to take you about 41 months. It's over 3 years. So we're just getting into this proportions here. We still have more to do. We only have 5 minutes. I want to tell you out of the homework what I want you to look at, because there's only a few things we'll be able to do at this point. This is back on page 19, I think. Man. We haven't done any of the work problems yet, so the homework really doesn't have anything. So I'm just going to give you a problem. I'm going to have to make up a problem, all right? Just something for you to practice, or just so I make sure you understand this idea. If Robert can type 40 words in 30 seconds, or, you know, I'm going to make them weird numbers so you can't try and solve this easily. In 32 seconds, then, all right, I'm going to have you do a couple of problems. A, how long will it take to write or type, sorry, to type 1,246 words. B, how,
Excuse me, you've
Yes.
missed, you omitted the word long in A, right? How long?
Robert can type 40 words, then how, yeah, how long, sorry, how long, obviously I can't type 40 words in 32 seconds. How long will it take him to type 1,246 words? And the next one is, how many words can he type in 3.5 hours? Be careful, I'm trying to trick you on that. That's the first problem. The second one, if a can, no, not a can, let's say if a hamburger has 735 calories, then A, how many calories are in 3.4 hamburgers? Yes, I misspelled that. B, how many hamburgers would you need to eat to consume 4,230 calories? Okay, so just this is all I want you to do for what we've talked about. Next class, we'll be able to get through the word problems for the homework, but for tonight, just focus on this. So do the same thing we did before. You're going to be using, first of all, this information that's given to you. Okay, that information will allow you to set up two fractions. Okay, one of them is going to have one thing on top and the other on the bottom, and then the other fraction will be that flipped over. And then you have to look at what you're looking for and create the proportion. You just got to make sure, like on the first one, you know, words on top, seconds on the bottom, or the other way around. Then for the bottom, hamburgers and calories. Make sure you get it right. Okay. And so I think what I'll do next time is we're going to do a poll at the beginning of class. And I'm going to say, this is number 1, this is number 2. I'm going to do a poll, and I'm going to ask you to answer, to put your answers in for 1A and B, for 2A and B. I want everyone's going to be able to put in their answer, and I'm going to collect those. All right. It'll be like a quiz type thing, just to make sure you're at least trying this. All right, everyone, have a great day.
Thank you.
See you on
Thank you.
Thursday.
Thank you. Thanks.